insert is totally standard, but insert or replace and insert or ignore is not totally standard. But that's okay. It works for SQLite, which is what we're doing. And so we have the title, album ID, length, rating, and count. And then we have a tuple that does all that stuff. And of course, the title is unique, right? The title is unique in the track table as well. And so we've inserted that. So the clever bit here is both dealing with new or existing names in these 3 lines. And we see that pattern twice here where we're doing that, okay? So there's not much left to do except run this code. Hopefully it runs. Python 3 tracks.py and library.xml. Whoosh! Okay, so that is my, so we found 404 of those dictionaries, 3D dictionaries, and now it's starting to insert them, insert them, insert them, insert them. And we can take a look at, so we can do an ls-l or dir on Windows, we'll see that we made a track database. We extracted the data from this library and we made a track database, and we have all these foreign keys. So let's go and take a look at the SQLite browser. File, open database, TrackDB SQLite, and come on up. Where'd you hide? I got it minimized, so there you go. Let's look at the database structure. We have an album, this is the structure, artist and track, we have no genre, and this is all like we did it by hand, except Python did all this work for us. If we take a look at the data and we start from the outside in, we have the artist names and their primary keys. Right, there's the artist names and primary keys. And then we have the albums, and we have the artist IDs. See the artist IDs, how nice those are. So we have the primary key here and the foreign key there, and then we have the title. And if we get to the track, we have the album ID, and away we go. So if I was clever, I could be able to type some SQL. Oh, great. If I was smart, I'd have had this in a paste buffer. So, select track dot title, album dot title, artist dot name, I think. Artist has names and albums have titles. Yes. Okay, so I can do that from track join album. Oops. Album join. Let me make that a little bigger. Bring that over here. Album track join album join artist. Now I need an on clause, and I can say track dot album ID equals album. Notice how I know the name that I named these things, and album dot artist. This is so great when you use a naming convention. Artist ID. Golly, I think that might work. So let's just see what we get when we type that into the SQL box here. Execute SQL. Run. Yay! I got it right the first time. Right, so that's basically my nice little joined up track list. Oh, I'm so happy that I got that right the first time. Okay, well, you can play with this yourself. Play with this tracks, maybe make an export of your own iTunes library and run it with that. And so I hope that you found this particular bit of code useful. Okay? Cheers. So our last major topic is called many-to-many relationships. And up till now, everything that we've done is what's called a one-to-many relationship. And that is, there are many tracks associated with one album. There are many albums associated with one artist. There are many tracks associated with one genre. And you can think of labeling, and as you look at data models, they put little labels on each arrow that tell you which end of the arrow is the many and which end of the arrow is the one. And so in this case, the foreign key is pointing to, there are many of these rows over here, many rows that point to one row over here. So it's a many-to-one relationship. There are various ways. Sometimes I'll put two arrows at this end and one arrow at that end. But whatever it is, this kind of thing we've been showing is a many-to-one relationship. And that's probably the most common thing. But there are times when you just can't model things with a one-to-many relationship. So like if you have a mother and children, well, that's a many-to-one relationship, and it's just fine, and that works fine. But sometimes you have a many-to-many relationship in that there might be many books. One book has many authors, and each author has many books. And so you don't have like the one side. There's no one. And so you have to end up building a table that what we call it, I call it a connector table. They call it a junction table on Wikipedia. But we need a little table that allows us to break a many-to-many relationship into, in effect, two many-to-one relationships in a connector table. And so this is a connector table. So you could think of this as, you know, there are many links here, but we don't have a way to model the many over here to here. And so what you do is you basically say, oh, there's a lot of these things. There's many that go to the one, the many that go to the one, and then in here you sort of create that manyness that you want to create. So it's probably just as easy to look at a sample of this. So let's imagine a learning management system where you're taking a class, and there are some people that are teachers and some people that are students, and many students are members of many classes. A student can be part of many classes, and a class has many students in it. So you can't really find the one end. And so what we do is we make a table called membership. And in that table of membership, we actually often don't put a primary key in at all. We simply put in two foreign keys. And if we're going to put a uniqueness constraint, we put a combination of the two foreign keys as the uniqueness constraint. So we say there can be duplicate user IDs and duplicate course IDs, but there can only be, you know, user ID, course ID combinations. That has to be unique. So you can make unique be more than one column. And so if you imagine a course table and a user table, there's a user ID, the name and email, and the course has a title and an ID. And then we have this little table that just is the connector table that shows the points out. And so we can expand this membership. So let's take a look at how that works. So we're going to create some tables, and these are very classic tables because these are the one end of it. So these are the one end of it. So it has a primary key, a title, a logical key, email. There's a primary key for course, and then there's text. So we add this unique to kind of indicate that it's a logical key. We're not going to allow ourselves to put any duplicates in here. Now the connector database here is a table member, and it has two foreign keys, user ID and artist course ID. And you can even model some data here. So I'm going to model role, which is going to be 0 equals student and 1 equals instructor. And then I'm going to indicate that the primary key or uniqueness constraint is the combination of the user ID and a course ID. Now when we say the primary key, it both limits our ability to insert duplicates, but it also allows the database to optimize its scanning because it knows that that combination is always unique, and so it can organize its disk structure and storage structure to understand how to look things up more efficiently, knowing that once it's found a user ID, course ID combination, it doesn't have to look any farther because they're unique. And so all of these contracts that we add speed things up, save storage, and makes things more efficient, but in ways we don't always know exactly how they happened. And so let's go ahead and make these. Let's go ahead and make these guys. I think I will start with a new database. I'm going to call it LMS for Learning Management System. No, I don't really want to do that one. And so I'm going to not create the table. I'm going to do everything in SQL. And so let me see if it's in my cheat sheet. Nope, that's not in my cheat sheet. So I'll have to fix the cheat sheet again for you. By the time you see the cheat sheet, all these things will be in there. So I'm going to go in here and I'm going to create table user. Actually, I'm going to grab them all. Watch this. Grab them all, highlight all these, go over to SQLite Browser, blast them all in, and then I'll put a semicolon at the